Welcome back, everyone. I am looking forward to talk about our lesson today um, to honor my audience from YouTube. Before I get into the lesson, please let me remind you about my website, mymathteaching.ca, or you can purchase the full set of my Introduction to Calculus course, including 100 video lectures. We show you step by step. If you purchase the full set of the Introduction to Calculus course 1 and course 2 together, the reduced price will be $80 USD. And that is the final sale. I will not reduce further, regardless how many customers I have. So let me talk about the topic today we will learn. Today, the topic we will learn is radical function. So we get into the specific function. And the first function we look at it is radical function and its transformation, as well as its characteristic. So I have laid out on the step to make sure that when I deliver the lesson to you, I will follow this guideline. So first, we will talk about the basic shape. Then we will talk about its transformation and tips on sketching. And then the third part, we will talk about sketching the radical functions. We can sketch using the linear or transformation or parabola. The fourth section, we'll look at how to solve the radical equations. And the fifth one is we will review and practice and the assignment. If you follow my course online, you'll be able to download the files and the practice package exercise and have fun with it, because it's not hard to sketch the radical function, but you will be amazed how we get into the details and how we look at it in sketching in terms of using linear function and using quadratic function, rather than using the table data. Now, usually the first thing we learn in sketch the function, we always use the data table. And that is a good way, however, and accurate in terms of calculating the coordinates, but it's a tedious task. So in math, we reduce the task by using the formula or using another method, another ways of handling how to sketch by hand and still produce the very accurate information of the graph. So let me get right into it. So first, I will show you the basic shape of the radical function. So let me, and then we will talk about the transformation. So let me have some more room here to show you. Now, if we use a data table, it will very much for the basic, right? So if we use the table, you will have an x coordinate and we have the y coordinate. Now let's talk about the first basic one. Let's say y equals square root of x. So if we create the table of data, we can sketch it very easily, right? So let's say if the function is, now Also, you know that we're not going to establish the negative side, right? Negative value, because you cannot take the square root of any negative value, right? If you key in the calculator, you will get the error message. So therefore, all of the x here have to be from the 0 bigger than 0. And therefore, let's start at 1, the easy one, or maybe 0, the easy one. So y will be 0 because square root 0 is 0. If it's 1, y is still 1. Let's say if x is 4, y will be square root of 4 will be 2. So based on this, we'll be able to get a basic radical function is very easily. So let's say this is 1, 2, 3, 4. So if x is 1, x is 0, y is 0. Stop right there. And if x is 1, y is 1. If x is 4 here, y will be 2. So the radical function have the basic one have a shape like that. It's always like a curve, right? Slightly bend away from the y-axis or above the x-axis and stop at 0. Now, we will not have a radical. We will not have the x value at the positive. However, due to the transformation of radical, we might have the radical this way if a reflection over the y-axis. Or we might have a radical this that way if a reflection over the x-axis. We might have this radical shift up by 1 unit, or we might have this reflection over the x-axis and shift down by -1 unit. So that is a basic feature about the radical. Now let's talk about the radical in terms of transformation. In terms of transformation, as you have learned with me, the basic transformation is vertical stretch by a factor of A, horizontal stretch or compressed by a factor of B. And then here I use another letter, which is in the previous, I use C and D. And because I want to show you the variety way of different type of textbook using it. So some textbook will use H, and some textbook will use, instead of D, we use letter K. However, it's the same concept. So we know that this is the vertical stretch or compress. This is the horizontal stretch or compress by letter B. And move left, move right. So I should have plus and minus as well, right? Depend on we move left and move right for horizontal. Shift and vertical shifted up or down by letter K. So we will, in this lesson today, we will look at the radical function in terms of their basic shape, and I will show you how to sketch its transformation like this. We can sketch it using the transformation, and that is the formal way we learn. The next lesson, I will show you how to sketch it easily using the linear or the parabola, depend on the equations. So let's take a look at how we're going to sketch this function based on the transformation today. Now, before we get into this new transformation like this, let me talk a little bit about its domain and its range, because that will be including in the it will be including in the basic shape, right? So let's talk about the basic shape of the radical function and domain and range. So let's look at the domain and range of this basic shape. So this is the function y equals square root of x. Now, let's talk about, and you know this point here is 1 and 1, right? So that is the important point to start the shape of the radical function, as well as this point is 4 and 2. Now, another very important point you should pay attention is the end point of the radical. Some function might wrap on the way, like example like this, right? It keep going this way and keep going this way. Or the linear function keep going that way and keep going this way. So they never have an end point. But in the radical function, we see the difference. We have the end point. So because we call an end point because the radical is not continue this way. It starts from here and it keep going. So some people refer this is the beginning point. Actually, it should be the beginning point, right? But for the image, we can refer this as the end point because it stopped here. It not go this way, right? So let's call this is the end point. Now, the end point here is 0 and 0 for the basic radical function. If we have a transformation, we might have a different end point. So the base point of this radical function, very important. So let me show you if I sketch this radical function based on the basic. Let's say if I want to create the radical function y equal negative square root of x. So obviously, you see that this base point 1 will be reflected over the y-axis. If we have, sorry, it should be the negative, should be inside, right? So this point will become this point. So it reflects over here. And the 4 and 2 will be reflected on the way here. And the end point here, 0 and 0, will stay the same if reflect over the y-axis. So it looks like this. So this is the function y equal minus square root of minus x. Now, let's say in another function, I want you to sketch y equal minus and also minus square root of x at 1. So based on this transformation, we will say, okay, so we have the first shape look like this. Now this shape will be also reflect over the axis. So at first, it looked like this. Look like this one. But now we're going to reflect is over the axis. And so it will, this point will reflect down here, and this point will be reflect down here. So we have a shape like this. If it reflect over the both the y-axis and the x-axis. And notice the endpoint is still 0 and 0. Now we're going to shift this up by 1 unit. So this is the almost the final draft, but our final draft will have to be shipped up by 1 unit. So this is the function we're going to ship up by 1 unit. So the point here will become here. The point here will ship up by 1 unit will be here. And any point on this draft will be shipped up by 1 unit. So the final sketching will be this one, which is this function. So you can see that the way we sketch the radical function is not bad, using this waypoint, right? And we notice the reflection of the y-axis, reflection both y-axis and x-axis, and shift up by 1 unit. So this is a feature of our radical function. Now let's talk about the domain and range. So anytime we look at the function, we should always look at the domain and the range of the function. So that is a very important, right, step in the sketching. So let's look at the domain of the basic function. So now I'm going to talk about the domain and range for this. So the domain for this function will have the notation like this. The domain is the set of on x value, right? So we have x, x1, x2, x3, x4, but we just represent by 1x here, right? So it's a set of x values such that this lies, this short line is stand for such that the domain is a set of x value such that on the x here have to be bigger than 0, right, for this basic one. So the x start this way, it got to be bigger or equal 0. And also the x belong to the real number. The real number including the irrational, the decimal point, any number, any value along this axis, right? From 0 further. So that is about the domain. Now let's talk about the range. So the range is the set of y, right? Y coordinate such that the y have to be, if it go this way, it means it can keep going, right? So the y can be start from 0 on the way up to infinity. So we can say such that y have to be bigger equal 0, just like this one. And y also belong to the real number. So that's how we state the domain and range for this basic radical function. Now let's do one of this domain and range for this radical function here. Here and here. So the domain for this function will be a set of x such that on the x have to be less than or equal 0. So for the reflection, it goes this way, right? So this is the one we're talking about, right? So the x have to be less than or equal 0, and also x belong to real number. So that's how we state the domain for this function. Now the range will be the set of y coordinates such that the y have to be bigger or equal 0, and y also belong to real number. So that's how you write the notation for the domain and the range of these basic features of radical. Now let's talk about this radical. Now this endpoint is 0 and 1. And this one is -1 and 0. So now for this one, which is this function here, the domain will be, you also can state the domain like this. A set of x such that x from negative infinity to 0. And you close the bracket. You can state like that as well. And the range will be a set of y such that the y have to be less than or equal from this point downward here. So the y have to be less than or equal number 1. And the y belong to the real number. Now you also can state like this as well because we use this notation. So maybe we might be as well use this notation. A set of y such that here you will open the square bracket, and we have square bracket like this because we including this value. So the y will be start from number 1 down all the way down to negative infinity. And for the down to here negative infinity, you can use the curved bracket like that. So that's how you state the domain and range of this basic radical function. So now for this one, I would like to show you how to sketch the formulae, how to sketch this function. Formulae like y plus 3 equal. So the first example, we will sketch y plus 3 equal minus square root of x. And the second example, we will sketch this second one here. Y equal 3 square root of minus x plus 1. So let's sketch the example 1 first. So I'm start from example 1, right? Now, before I sketch this, let me rearrange this function a little bit. So this function, I will rearrange like this. Y equal minus square root of 2x. I move the number 3 to the right-hand side because we separate from the y function, right? So let's move this number become minus 3 when we move to the other side of the equation, right? So now we can see that this function have a horizontal stretch, horizontal actually compressed by 1/2, right? Remember we say for the horizontal we have to reverse. So we know this factor for horizontal will be compressed by 1/2, followed by the reflection over the axis. So this is the reflect over the axis and will be shipped down by 3 units, right? So this will be shifted down by 3 units. So how do we gonna sketch this complex radical function? The easy way, if we use a transformation and we want to be accurate, then we should plot the base points from the basic function. And then from the base point of the basic function, we can start sketching our transformation, right? So let's talk about the basic point. So the basic point, if x is 0, y is 0. If x is 1, y will be 1. If x is 4, y will be 2. So 1, 2, 3, 4. Y will be 2. So our base point will be here. So let's put the dotted line as for the basic one. This is not the real sketching, right? We don't want we just want to use this base point to shape it, right? So now we say we have to shrink this x by 1/2, right? Horizontal compress by 1/2. So if x is 1, we'll move it become 0.5, right? Half of it. Now, keep in mind that when we shrink the x, we not shrink the y. So our y still stay at this level, right? But our x will be shrinkled. So this point will move toward the y-axis. This point will become this point, right? Because we take half of the x. So this point will move to half, so 4 will become 2. So, and the y level is same, so that will be here. So now, so let's get rid of this point because we already done with that. The 0, if we take half of the x0, it's just 0. So this point is not changing. So now we can reshape this. However, we have to reflect this point to over the axis. So this point will reflect to -1, so it will become here, right? So reflect this way. And this point will reflect down from -2 this way. So this point here reflect down here, so we get rid of that. Get rid of that. So this is the 2 point, and this point reflect here, it just stay the same. Also, keep in mind that these, so let's shape a little bit our okay, so let's shape a little bit our radical function, look like that, right? So now this base point will move down by 3 units. So the 0 here will move down 1, 2, 3. So this point will become this point right now. So let's get rid of that. This point right here will move down 1, 2, 3. So become this point. This will move down 1, 2, 3. So at the end, our final radical function will look like this using the transformation sketching. So that's the shape of our radical function. Now let's mark this endpoint. This endpoint will be -0 for x and -3 for y. This point will be, now this will be -2, shift down to 3 units, so that will be -5 for y, and the x coordinate is at 2. So let's mark some basic point like that. So this is how we sketch the example 1. So let's find out the domain and the range of this graph. So our domain for this graph will be a set of x such that x will be from 0, right? It not go this way. So it not reflect over the y-axis. So will be a set of x such that x have to be bigger equal 0. And x belong to real number. Now the range will be the set of y such that the y have to be start from here on the way down here, less than or equal -3, right? and belong to real number. So that's how we sketch the function, we plot some basic point, we state domain, and we state the range. And that's how we perform the sketching of our radical transformation. There is the last example here, example 2. I'm going to show you, and I will end this video here. In this video, you will learn with me about the sketching of the basic shape of the radical function, including with the transformation. In the next video, you will learn how to sketch it in the way of using linear and parabola, and that will be fun. Okay, so let me continue with the last example here we have, right? So before we do the last example here, I'm going to have to erase all of this stuff. And if you register to my course, you will be able to keep all of this without the missing information when I erase it. So let me start with the new fresh, right? So we'll get rid of this. Now we're talking about example 2. So let's get rid of this, and we start with this fresh new function. For this new function, maybe let me move it up a little bit so we have more room, right? So y will be equal, this is the vertical stretch by factor of 3. Radical inside, we have a reflection over the y-axis, and we have a positive sign. So we know our transformation will be. Let's talk about the transformation first, right? So what the transformation we have here? Number 1, and make sure you know that we have to follow the order, right, of the transformation. So let me put this up a little bit. So in K, we need more room. So the first transformation is vertical stretch. So our A equal factor by 3, and this is vertical stretch. The B value will be equal to -1, right? This is B value -1. Now this negative shows us reflection over the y-axis, right? So reflect over the y. Reflect on the y-axis and not the x, right? So what else? Then we will move to the left, right? So the C here is -1. And the reason, because the formula itself is negative, right? And then when you do negative, times negative will become positive like that. So we know that based on the sign, we know we move the function to the left because the C is -1. So move left, right? Move left. That's it. We don't have a vertical shift, right, outside here. So let's start sketching. So again, to use a transformation, I'm going to start from the points of base points, right? We're going to use the base point of the basic feature. So the radical basic feature, the base point start from 0. And then if x is 1, square root of 1 is y is 1. If x is 4, square root of 4 is 2. So these are the basic graph, and we're going to use this base point to sketch it. So now this base point will multiply by 3, vertical stretch by factor of 3. So 1 times 0 times 3 is still 0, stay there. 1 times 3 will become 3. So this will shift up here, right? And this point here is 2 times 3 will be 6. So this is 2, 3, 4, 5, 6, right? Up to here is 6. So this point will move up here. Now, so we get rid of this one, get rid of this one. Follow the reflection, right? We follow by the order, reflection over the y-axis. So this point will reflect over here, and this point will reflect over here. Now, after the reflection, we also have to shift to the left by 1 unit. So this point will shift to the left by 1 unit. So let's get rid of that. And this will be shift by 1 unit. So get rid of that. And this point 0 will be shift to 1 unit as well. So it will be here. So now, to sketch this, this is the final shape of our radical function. So this is not bad, right? You see that it's easy to sketch the transformation of radical function based on the base point, and I show you. So I guess this not too long video, and I hope you enjoy my math teaching today online. Please register to my course if you need it, if you want to understand more about math. And I said that this is the time when have never been such a strong push for mathematics education. And if you register to my online courses, you can learn on the details, on the information there. You can revise, you can rewatch, and you can relearn at your own space to understand the mathematics in details and formulae based on my course structure. Now, one thing I would like to remind you, right? I know that some of you will be busy with your course in the school, and your teacher will maybe teach the same topic or maybe different. If you are in the Math 12, right, it's very much the same, except that the order might be switching around. Maybe I'm teaching the function with the radical first. Some teacher will start with the polynomial function. However, if you learn my course in advance, right, it's same like tutoring. And the benefit of learning in advance, or even though learn after, because learning means repeating, rehearsal, and review. Now, anytime I learn math, during the process, I'm just trying to process the data. I not understand very much. But after the review, so review part is where the time when you absorb the materials. For the common regular person, I mean, I'm not talking about you very bright and you genius in math. Now I'm just a regular person. I'm learn math in the way traditionally. So I feel that is nothing wrong with traditional learning, like we used to criticize about instructional teaching techniques in mathematics. I just found without the teacher showing you this stuff, how do you go to discover about math? And the basic, any subject you have to learn from the basic, and then you can fantasize about that, right? Like bondroom, you learn 2, 3, 4, 1, cha-cha-cha. In accounting, you're going to start with the spreadsheet, but you still have to learn the basic to be able to understand the software. The same like in math. So there's nothing wrong, except that math has a lot of information in which we call a basic. So all the way from elementary to high school, on the basic of math you have to learn. So we're not going to have a lot of time to be able to unless you learn in advance and you're very good at math and you try to learn it in advance, then you can speed up and you can creative about it. But I try to stay away from creative and make math fun in the wrong way, right? Because math only have one formula, only have one answer. So if we fantasize about math, we create, but not based on the foundation, not based on the foundation basic, which is we know that it's right, it's correct before we create, right, the new beautiful. As I am a regular person, I just feel that only to understand about the basic structure information on the multiply table, on the division table, on the factors and thing in math, it takes more than enough time for you to digest, absorb it already. So we're not going to have time to do some creative activity unless you try to perform it based on the information you learn from the instructional teaching from the teacher. You understand about quadratic function, you understand radical function like this. Now you can make a project, and that's we call creative. Then that's okay. But at this level, we have a lot of information in our curriculum of Math 12. If we use it once in a while, you can have a project. You're going to have 1 or 2 projects. You're not going to have time to do 10 projects. If you try to do 10 projects for creation, then you're going to lose on the basic information you're supposed to learn in the Math 12 curriculum, including on the all the functions, and then the sketching, and on the permutation, combination. So everything is informative, like one way or the other. If you spend time for 10 projects, you're going to lose a bunch of information in the curriculum, and you want to learn more and more in the curriculum, so you know more about the basic structure and basic step before you can move on to move up to calculus and thing. So that is the reality in my experience teaching math for 13 years. I felt that way. It's up to your debate or opinions, but I just feel only for learning the basic information, we already do not have time in our curriculum. So when I was teaching in my classroom for my student, I create quadratic function project, but I had to deliver the basic formula of the quadratic function, basic sketching like this, before we can complete our creativity project, right? So anyway, I know that I'm talking out of the topics again, but this is the end of my video. So I hope you enjoy my chat as well. Bye for now, and I will see you in the next video. And thank you for watching.